This is video example problem 816, and it's from section 2 of chapter 8. The topic is, or the type of problem is called a confidence interval estimate for the mean where sigma is unknown. And most of the time sigma is unknown, so this is a pretty common kind of problem that we would have. And this problem is found on page 261, problem 816 of the chapter, so you can follow in your book as well, or you can just look at it here on the screen. And this is the problem. I'll just kind of read it, and you can also see it on the screen here. It says, a survey of nonprofit organizations showed that online fundraising has increased in the past year. And one of the key things as you read a word problem is to look for the key words. And so a key word here would be, and I can use this maybe as a pointer, would be increased. Okay, so online fundraising has increased in the past year. Based on a random sample of 55 nonprofits, the mean one-time gift donation in the past year was $75 with a standard deviation of $9. Okay, so we have some information given here. We have a random sample of 55. We have a mean of 75 that we found in our sample and a standard deviation of 9. It's important to recognize that that standard deviation of $9 came from the random sample of 55 nonprofits. It was not given to us, so that means it's going to be the sample standard deviation, which is S, rather than sigma, which would be the population value if we were given that information. That helps us to determine that this is going to be a T problem. We've got to use a T form of the formula because the standard deviation for the population is not given. So the problem says, construct a 95% confidence interval estimate for the population mean one-time gift donation. Interpret the interval constructed in A. Okay, so the first thing we want to do is just write down the information that the problem gives us. X bar is equal to 75, N is equal to 55. Notice S is equal to 9. Okay? And the T value, we have to find a critical value of T. In this case, is going to be 2.0049. And we'll show you on the next slide where that number comes from. It's based on N minus 1 degrees of freedom, which is 55 minus 1, 54, and an alpha level of 0.05. Remember, if it doesn't tell us anything else, we always assume 0.05. So we have 95% confidence interval is what they're asking for. So we go back here, see in part A there it says construct a 95% interval. So that's how we knew alpha was 0.05 and we wanted 95% confidence. So why are we using this formula? We are interested in estimating the mean, and sigma is unknown. So we're interested in estimating the mean. Sorry about that typo there. Interested in estimating the mean. Sigma is unknown. We're assuming a random sample and a normal distribution. So these are the important assumptions. Random sample, normal distribution. Sigma is unknown because remember we found that it came from the sample back here. 75 was based on the sample of 55. So that's why we know that sigma is unknown. We're assuming a random sample, normal distribution. We want to estimate the mean. That's what we're interested in. And we're going to use a confidence interval for the mean t-test. So that's the formula we're going to use. Okay, to find the critical value. Critical value of t is 2.0049. Remember we showed you that a couple slides back. Where did that number come from? That number is based on 54 degrees of freedom, and the alpha level is 0.05, so what I have to do is divide that by 2 because a confidence interval is always two-tailed, plus or minus. So 0.025 is my upper tail area and my degrees of freedom are 54. So looking at the table here, upper tail area 0.025 and the degrees of freedom are 54, so we find where they intersect on the table. That gives me 2.0049 as my value. Okay? So now what I do is I plug into my formula. My formula says, here it is at the top, x bar plus or minus T alpha divided by 2 times S over the square root of N. So x bar, if we go back a slide or two here, we see that x bar was 75, N is 55, and S is 9. Okay, so come over here, we plug those numbers into the formula. 9 goes for S, 55 is N, and then we plug in our value for critical value of T, which is 2.0049 that we found in the table, and we solve, and we get 75 plus or minus 2.4331. We add and subtract that from the sample mean, which was 75, and we get an interval that looks like this. 72.5669 is less than or equal to mu, which is less than or equal to 77.4331. So that is the solution to part A. So let's go back and see what the question said again. Construct a 95% interval estimate for the mean one-time gift donation. So that was our answer to part A. Now, part B said, interpret the interval constructed in A. So we have the interval. What does it mean? This is how we would say, explain what we came up with. We're 95% confident that the population mean of one-time gifts is between $72.57 and $77.43. The key question is, since $75 is contained in the interval, we cannot say that the mean level of one-time gifts has increased. Okay, in other words, if this interval that we came up with, we expect the level of gifts to be between $72.56 and $77.43. But because that contains the old value of $75, we can't say that the mean level of gifts has increased. If both of these values were greater than 75, that would tell me that we could say, yes, the level of giving has increased.